Preprocessing few discrete variables. Welcome back. We've successfully preprocessed the time-related features. In this lecture, we will explore what to do when we've got discrete features. Let's go through the variables and variable types from the loan data data frame again. We will focus on several discrete or categorical variables, namely grade, subgrade, home ownership, verification status, loan status, purpose, state, and initial list status. We may not use all of them, but it doesn't hurt to preprocess them anyway. As you'll see in a minute, it takes minimum effort. What we want to do with the discrete features is to create dummy variables for all of their categories. Dummy variables are binary indicators. They take the value of 1 if the observation belongs to a category, and the value of 0 if it doesn't. A good example of a categorical variable is biological sex. You may have a column which denotes biological sex of people. It may contain strings, such as male or female, or M and F. In order for this information to be useful for a statistical model, it has to be numerically represented by dummy variables. In this case, you would have 2 dummy variables, one for male and one for female biological sex. The first dummy variable will have a value 1 if the person is male, or a value of 0 if they are female. Respectively, the second dummy variable will have a value of 1 if the person is female and a value of 0 if they are male. Perhaps you have already noticed that the second dummy variable is actually redundant in terms of information. All the information for the 2 categories can be represented in one dummy variable. Everyone who isn't male is a female, or everyone who isn't female is male. In terms of dummy variables, it would be enough to have only the first dummy variable, where male individuals are assigned the value of 1 and female individuals are assigned the value of 0, to represent all the information. Similarly, it would be enough to have only the second dummy variable, where female individuals are assigned the value of 1 and male individuals are assigned the value of 0 to represent all the information for biological sex. So it is safe to conclude that we need only one dummy variable to represent the information for 2 categories. Following the same logic, we need just 2 dummy variables to represent all the information for 3 categories, and, logically, 3 dummy variables to represent all the information for 4 categories. Try to imagine what that would look like. If you had k categories of a variable, you would need only k1 dummy variables to represent the information. Remember that. It would be very important when we start building statistical models later on. Alright, now let's start creating dummy variables for our categorical variables. I'll show you how to do it with the grade variable, and then we are going to apply the same steps for the rest of the categorical variables. From my experience, it will be best to create a new data frame, where we will store all the new dummy variables and then concatenate this data frame to the loan data data frame. Effectively, this means we will append the columns with the dummy variables to the columns of the loan data data frame. First, let's see how dummy variables are being created. Pandas has a built-in function for that called getDummies. Let's apply it on the grade variable. Nice. We get 7 dummy variables, matching the exact number of the categories of the grade variable. Take a closer look at how the dummy variables are structured. On each row, there is only a single 1, and the rest of the values are zeros. The value of 1 shows what category of the variable grade the observation belongs to. For example, the category on the first row is B. Hence, the dummy variable B is 1, and the rest are zeros. The observation on the second row has grade C, so the dummy variable C has the value of the 1, and all the other dummy variables are zeros. Note that the getDummies function creates as many dummy variables as there are categories by default. Also note that the newly created variables have the same names as the categories. If we are about to append these variables to our data and use them for statistical analysis, we'd want their names to be a little bit more explicit, wouldn't we? At least we can add the name of the original categorical variable that the dummies describe. We can do that by setting a prefix in the getDummies function. Let's set the name of the original variable as a prefix, grade. Also, we can set a separator between the prefix and the rest of the variable name, that is, the category labels. That the proper argument is prefix sep of the getDummies function. I'll set it to be a colon. After running the cell, we get the same dummy variables, but with slightly more descriptive variable names. Okay, great. Using the same methodology, we can preprocess the other categorical variables we mentioned. We will assign all of the resulting dummy variables as a list to a new variable called lone data dummies. We make them a list by itemizing them, separated by commas, and enclosing the whole sequence in brackets. Awesome! Now we've got a list of dummy variables in the lone data dummies variable. To make it a data frame, we can use the pd_concat method. And we are almost done. Lone data dummies is now a nice data frame with all the dummy variables we need. What's left is to concatenate it with the original lones data frame. We can use the pd_concat method. Concat here comes from concatenate. We have to specify whether we want to concatenate the inputs by rows or by columns. We do that with the axis parameter. If we specify axis equals 0, the inputs would be concatenated by rows. What we really want is to concatenate them by columns, so we specify axis equals 1. And now, let's see whether the new dummy variables are really appended to the data frame. Yes, they are. Good job! Let's wrap it up here. In the next lesson, we will deal with missing values. Thanks for watching.